I'm Blaine Sunder with AWS Training and Certification. I've been teaching technology for more years than I'm willing to admit. After spending time teaching the newspaper industry, I moved to AWS, where I've taught classes globally on many different disciplines, such as security, cloud architecture, DevOps, big data, AI and ML, and theater history. My mama was a teacher. My daddy was a teacher. My grandpa was a bartender. I was born for this.
Hi, I'm Morgan Willis, a senior cloud technologist at AWS. I started in the IT world about 10 years ago, and along the way, I decided that I was missing something. I missed the helping and teaching aspect of IT that I had in my first job in IT support. So I went into teaching software development in different areas around the US, and then I eventually landed here at AWS, where as a cloud technologist, I get to support others in their cloud journey every day.
And I'm Rudy Chetty. I come from sunny Cape Town, South Africa, home of biltong, boerewors, and bunny chow. I'm a solutions architect and have been with AWS for over 3 years. Teaching is my passion, and I can't wait for you to dive into the course and learn. Ngiyabonga Gakulu, feels geluk, thanks a lot, and good luck.
This course is going to cover all the essential information that you need to understand to be comfortable discussing AWS, to know why it's beneficial to your business.
AWS offers a massive range of services for every business, starting with basic elements like compute, storage, and network security tools, through complex solutions like blockchain, machine learning, or artificial intelligence, and robot development platforms, all the way through very specialized tool sets like video production management systems and orbital satellites you can rent by the minute.
All that, however, is way more than we have time to cover in a foundational class like this one. So let's simplify the conversation by starting with the fundamental cloud compute model.
Almost all modern computing centers around a basic client-server model. Now, I know it can be more complicated than that, so let's take a look at our coffee shop.
This coffee shop is going to give us some real-world metaphors to help you.
Okay, so we have to keep in mind the phrase client-server model. That's really important.
To understand why AWS can change the way your IT operates.
Let's make Morgan the server, the barista, and I am the client, the customer. I make a request. In this case, it is for coffee. Now, in the computing world, the request could be anything. It could be rain pattern analysis in South Africa, or the latest x-rays of your knee, or videos of kittens. Whatever is the business, basically a customer makes a request, and with permissions, the server responds to that request. All I want is a caffeinated beverage. Morgan represents the server part of the client-server model. In AWS, she would be called an Amazon Elastic Compute Cloud, or EC2, an EC2 instance, a virtual server. So from an architectural point of view, the transaction we did is really simple to explain. I, the user, made a request to Morgan, the server. Morgan validated that the request was legitimate. In this case, did I give her money? Then she returned a response, which in this case is a berry blaster with extra caramel shots.
Now, in the real world, applications can get more complicated than just a single transaction with a single server. In a business solution that is more mature, it can get beautifully complex.
To avoid this complexity, we're going to start simple. We will build this discussion out so it is easy for anyone to understand how these concepts build on each other. So by the end, those complex concepts, they'll be easy to understand. Let's start with a key concept to AWS, and that is you only pay for what you use.
This principle makes sense when you run a coffee shop. Employees are only paid when they're in the store working. If Rudy or Morgan are off the clock, well, then they don't get paid. The store owner simply decides how many baristas are needed and then just pays for the hours they work. For example, The coffee shop is about to release a new drink, the Pumpkin Monster Spice. In anticipation of this launch, you could always staff your shop with a dozen baristas all day long, just in case you suddenly get an unexpected rush at some point in the day. Only, let's be honest, for most of your day, you don't have near enough customers to justify paying for all those employees.
And yet, this is exactly what happens in an on-premises data center. You can't just snap your fingers and triple your capacity. At AWS, you don't prepay for anything, and you don't have to worry about capacity constraints.
When you need instances or baristas, you just click a button and you have them. Then when you don't need them, another click, and they go away, and you stop paying for them. The same way you don't pay for employees for hours that they're not working.
So, pay for what you need becomes the first key value of many for running your business on AWS. And that is really why we're here, to help you understand how AWS is built to help you run your business better.
We hope you stick around for the entire course as we dive deeper into these concepts and help launch you on your journey towards being a cloud practitioner.
Okay, so in this video, basically we are learning together, you and I. So far we learned client server model. So it's very important for this segment. So client server model is when the client is interacting with the server. So in this case, you have a virtual servers for Amazon, right? And the way the client interacts with the server is, suppose you are using, let's say you are using an application called Soundbug Audio, right? Soundbug. And when you sign up for Soundbug, you type in your information, your emails, your name, okay, so on and so forth. And you are able to sign up. So the next time you want to sign back in, basically what your action will trigger the response, it goes to the server, and the server will verify the information that you put in. Then once your information are verified, then you will be able to log in. So this is the simplest version of a client server model. So you're basically interacting with server. You are doing something, and it triggers a response from the server. So let's say if you are using a delivery app, right, or ride sharing, you send the request. The request will go to the server, right? And I mean, yeah, I'm not sure this is going to be the same model, but let's say what example? Let's say you want to pull up an old video from a search box from YouTube, right? So you type the name, and then you click. Then it goes to the server. The server look for that video and brings back. So that's called client server model. Okay, let's go to the second one. The second one is Amazon EC2. So you have, this is very simple. It's Amazon EC2 is basically means the virtual server instead of so you have physical servers. Physical server meaning you have a computer, right? On the computer you have a server. But you do have also a physical, I mean, a virtual server. So it exists in the cloud. So in this case, you are using the server of Amazon. But keep in mind, they do have physical servers, but for some reason they say the cloud. So for you, it's a cloud, right? So you rent the cloud, the virtual server, and you rent it from Amazon. They take care of heavy lifting. So basically, think about this: instead of you using physical servers for your businesses, they take away all of that, right? They have a database, data centers of a lot of servers, and they are renting the space to you as a customer. So, I just want to simplify. So they have a lot of database of servers, and you are a customer. You rent from Amazon. That's why it's called cloud. For you, it's a cloud. So everything, all the data that you have are stored in the servers of Amazon somewhere. So let's not think that cloud it doesn't have to do with physical service. It has to do with physical service. For you, it's not a server, but you're basically renting a space somewhere else. That's what it means. And Amazon EC2, that the meaning of that is Amazon Elastic Compute Cloud. Amazon Elastic Compute Cloud. So it means physical. It's very simple. It's a virtual server. Amazon Compute Cloud is a virtual server. That's what everything, it's very simple to know. So let's move on to the second model. Okay.
Before we get deeper into the pieces and parts of AWS, let's zoom out and get a good working definition of cloud. Cloud computing is
Okay, so this one is important. We have to remember this. So I'm gonna make some writing so that we don't have to forget it. Okay. So what is cloud computing? So cloud computing So we have cloud computing. The meaning of cloud computing is going to explain to us right away. So I'm going to write it first, but then so the cloud computing means the on-demand delivery of IT resources over the internet with pay-as-you-go pricing. So the on-demand of delivery, the on-demand delivery of IT resources over the internet. With pay-as-you-go pricing. So the on-demand delivery of IT resources over the internet with pay-as-you-go pricing. So that's the meaning of cloud computing. Okay, let's move forward.
Is the on-demand delivery of IT resources over the internet with pay-as-you-go pricing. So let's break this down. On-demand delivery indicates that AWS has the resources you need when you need them. And you don't need to tell us in advance that you're going to need them. Suddenly you find yourself needing 300 virtual servers. Well, just a few clicks and launch them. Or you need 2,000 terabytes of storage. You don't have to tell us in advance. Just start using the storage you need when you need it. Don't need them anymore. Just as quickly you can return them and stop paying immediately. That kind of flexibility is just not possible when you're managing your own data centers. The idea of IT resources is actually a big part of the AWS philosophy. We often get asked why AWS has so many products. And the answer is really simple: because businesses need them. If there are IT elements that are common across a number of businesses, then this is not a differentiator. Take a MySQL database as an example. If your business runs a MySQL database, does your ability to install the MySQL engine make you a better company than your competitors? Well, probably not that. Do you keep backups in a way that makes you superior to other players in your vertical? Again, doubtful. The data inside your database, now that's critically different. The way you build your tables and manage the structures absolutely separates you from the competition. But the engine is just the engine. At AWS, we call that the undifferentiated heavy lifting of IT.
Okay, so let's write down this phrase, the undifferentiated heavy lifting of IT. So let's write down. So this one is important. Undifferentiated. Heavy lifting of IT. Okay, let's go back.
Tasks that are common, often repetitive lifting of IT. The undifferentiated heavy lifting of IT. Tasks that are common, often repetitive, and ultimately time consuming. These are the tasks AWS wants to help you with, so you can focus on what makes you unique. Over the internet seems simple enough, but it implies that you can access those resources using a secure web page console or programmatically. No additional contracts or sales calls are needed. With pay-as-you-go pricing, we re-emphasize what we pointed out here in the coffee shop. You don't staff a shop with employees 24 hours a day at the same levels you do during peak hours. In fact, some hours you might not even staff them at all. So why pay for developer environments, for example, on weekends if your developers aren't working on the weekends?
Okay, so let's do a recap for this one. So cloud computing. So we have the cloud computing. So the meaning of cloud computing, it's important to understand so that we can understand the meaning. The on-demand delivery of IT resources over the internet, right? So the on-demand delivery of IT resources over the internet, pay-as-you-go pricing. So let's break it down. It's very simple because sometimes we get lost in the terminologies. Meaning the on-demand delivery of IT resources over the internet, pay-as-you-go. So you decided to have a cloud, right? Let's say instead of storing your data on a physical location in your office or on your computer, you decided that you wanted to save it somewhere else. And Amazon makes it easier for you to take the data and store it for you. So that's how it gives you all the resources, right? It give you all the tools necessary for you to be able to operate your servers in their system. And by doing that, they are also giving you prices based on what you need. So that's what the cloud computing is. It could be, so it's not only Amazon, Microsoft, they do the same thing. A lot of other companies do the same thing. Okay. So the other terminology phrase that he used is undifferentiated heavy lifting of IT. So in this case, according to Amazon, what they want to do is they want to take away all the tax and repetitive tax and time-consuming tax, so that you are as a business owner, you focus on on getting customers and focus on the money basically. And let's say you have a server and you don't have an IT guy to take care of it, and you have clients that you need to speak to. You don't want to go back into server room and try to fix this stuff. That's not your goal. That's not your role as a business owner. So, and then if you do have a physical service and something goes wrong, I have done some work where I dealt with small businesses. They have a lot of computers, and then they have network issues. And, they call me, and I was able to help them with their network. So, but if you are dealing with Amazon, right, with cloud computing, you don't need to go through all of that. So they will be able to take all the heavy lifting, right, and they will be able to take care of it. And case in point, I have an application, right, which is available. A lot of people are using right now, which is called Soundbook. So the Soundbook application is Soundbook Audio. I don't have a physical service, right? I do not have a physical service because it's not necessary. So what I use is I use a company. They give me the resources, right? And I host all my data on their servers, and I pay them yearly, or sometimes on a monthly basis. So this is an example of cloud computing. I don't have anything to do. I just log in and see my servers online and making sure that everything is working perfectly fine. I don't need to buy a physical computer, a physical server, and I put it in my office. Okay, so it's very important for somebody who wants to build business, right? You gotta be careful, especially let's say if you want to have a website that have services. You don't need a physical service. Okay, today it's very rare that people even need a physical service. Physical service you need in only a specific case, which is we're gonna discuss. I think they will be discussing further. All right, let's move on. Okay. So let's see. Okay, let's read some of the can understand. So there are three types of cloud computing. We have cloud-based, cloud-based computing. Cloud-based computing. Okay. We have on-premises process compute. I'm sorry, cloud-based deployment. I'm sorry, cloud-based deployment, not cloud-based deployment. And the on-premises deployment. On-premises deployment. And then the other one is deployment. Okay, the other one is what? What's the last one? Hybrid deployment, yeah, hybrid deployment. Hybrid deployment. Okay, so let's read it first, then we go. I'm gonna get back and. At the cloud-based deployment. So in this model, so for the cloud computing, we said there is a cloud-based deployment, on-premises deployment, and a hybrid deployment. Cloud-based deployment meaning all your servers, okay, will be in the cloud, will be managed by a company, by Amazon, by Microsoft, by Oracle, by any other company, you know, and basically you can start design and build the new infrastructure on the cloud, and that they can also migrate your existing. Let's say you have existing servers, physical servers, they will be able to transfer that to the cloud. So this is the model of the cloud-based deployment. Okay, let's go to the next one. The next one is on-premises deployment. this one is on premises. As the word, as the phrase indicates, on premises deployment, meaning basically having physical infrastructure, physical servers. That's what it really means. And so the other thing that we have to keep in mind is on-premises deployment also is the same as private cloud deployment. So that's the same meaning. So hybrid deployment. So let's go to the hybrid deployment. What do we have? This model, and this hybrid model, meaning two different things coming together, right? And so we have the cloud-based and on-premises based working together. This is what hybrid means, because a lot of people, they have all the legacy system, meaning IT infrastructure. They don't want to just move everything to the cloud. Okay, they want, for some reasons, depending on their businesses, right? They are required to have physical servers on premises. Okay, maybe for precaution, even cloud. I don't know. I'm not quite sure, but they just want to be sure that they have the data on the cloud, right? And also on their servers in their businesses. So hybrid deployment, you have the cloud-based and you have the on-premises based working together in hand. That's what it means. Okay, let's go to the next step. What do we have here? Okay, we have here benefit of cloud computing. So some of the benefits, consider why a company might choose to take particular cloud computing approach when addressing business needs. To learn more about the business, expand each of the following: trade upfront expense for variable expense. Trade up, that's so. We're discussing some of the reason why it's beneficial to have cloud-based infrastructure. Okay, stop spending to run and maintain data centers. Stop guessing capacity. Benefit from massive economies of scale. Increase speed and agility. Go global in minutes. Okay, so let's quickly go through those ones. So in this scenario, what it means is the benefit of cloud computing is, first of all, it is cost effective and it's also secure, right? It's also performance wise, it is much efficient, right? If you do have a lot of users and if you have growing users, you don't have to buy another server to maintain, or I don't know, to keep the traffic. But with the cloud computing, the system just adjusts itself, and it can scale automatically, and you don't have to buy a physical service. And it's also, you don't have to guess about it. It basically, makes it easier for you to make the system seamlessly adapt to the demanding, to the increase of the customers, to the increase of the activities. Okay, so let's say if you have a small business, you have 100 customers, and then suddenly you're getting 1,000 customers. So the system will adjust and it scale by itself. And also in terms of performance, it will be, very efficient. And lastly, it goes global. So you don't have to, the customer don't have to wait for another system to be installed in order to access your services. So these are some of the benefits of cloud computing. All right, let's move on. Okay, let's move on to the next one. So we have a quiz. Okay, so I did respond to the quiz. So I just I'm gonna hide it from you so that you'll be able to respond to the quiz. Since you are following along, so let's see. The quiz is, so I'm gonna read it, and you tell me which one is the right response. So the question is, what is, oh, I'm sorry, oh, okay, it's not, all right, let's do it. So the question is, what is, right? What is cloud computing? Okay, number one, backing up files that are stored on desktop and mobile devices, prevent data loss, deploying applications connected to on-premises infrastructure, running code without needing to manage or provision servers, on-demand delivery of IT resources and applications through the internet with pay-as-you-go pricing. So remember the definition of the cloud computing that we have discussed earlier. So from the 4 responses, which one is the correct one? So I'm going to give you some time to think about it. Okay, so the correct response is the last one, right? The last one is the correct response. What is this? Oh, yeah, okay. Somebody got it. You got it. Yeah, you got it. So the last one, yes. The last one is the correct response. So the correct response is, let me put it here. This one is the correct response. The on-demand delivery of IT resources over the internet with pay-as-you-go pricing. This is the right response. So I'm going to submit it, and let's move on to the. All right, we have, okay, the next questions. What is another name for on-premises deployment? Okay, what is another name for on-premises deployment? A, private cloud deployment. B, cloud-based application. C, hybrid deployment. D, AWS cloud. So you have some time to think about that. So basically what it means is, what other terms we use for on-premises deployment? Instead of saying on-premises deployment, what else, a term that we use that has the same meaning, interchangeable? Private cloud deployment, cloud-based application, hybrid deployment, AWS cloud. I'm waiting for your response. Thank you for the comment. Okay, so the answer is the first one. The first one is private cloud deployment. Private cloud deployment. So we can say on-premises deployment or private cloud deployment. Why we say on-premises deployment, meaning it's a private. So you have a business and you have the infrastructure on-premises, right, inside your office. So that's called on-premises. So it's basically mean cloud, private cloud. Okay. So let's move on to the third one. What does the scale of cloud computing help you to save costs? I'm sorry, how does the scale of cloud computing help you to save costs? You do not have to invest in technology resources before using them. The aggregated cloud usage from a large number of customers result in lower pay-as-you-go prices. Accessing services on demand helps you to prevent excess or limited capacity. You can quickly deploy applications to customers and provide them with low latency. So the question is, how does the scale of cloud computing help you to save costs? So the scale of cloud computing, okay. So the answer is B, right? Is the aggregated cloud usage from a large number of customers result in lower pay-as-you-go pricing. So in this case, the reason the answer is B is meaning if your business is scaling in terms of the cloud, right? If you're using small storage, you actually pay more for that. But if you're using bigger storage, bigger plan, as your business increases, the prices will adjust. The prices will go lower, right? So if you take example of you have, let's say, some of the tiers that they have in some website. So you go there and let's say you want 100 emails. So if you want 100 emails, you have to pay $10. If you want 50 emails, you pay $15. So you see the difference? So if you want 50 emails, 100 emails, you pay $20. So the more you're scaling, the price will be less. So that's what it means. Okay, let's move on. Okay, all right. So we are at the end of the first model. Okay. All right, so this one is module 1. The module 1 is done. Okay, so let's see. Okay. All right, let's move on to the module 2. All right, module 2 introductions. Summarize the benefits. Learning objective in this model, you'll learn how to describe benefit of Amazon EC2 at a basic level, identify the different Amazon EC2 instance types, differentiate between the various. Okay. Let's just watch the video.
In this video, we are going to talk at a high level about a service called Amazon Elastic Compute Cloud, or EC2. If you remember from our coffee shop, the employees are a metaphor for the client-server model, where a client sends a request to the server does some work, and then sends a response. That example is for the coffee shop, but the same idea applies to other businesses. Your business, whether it be in healthcare, manufacturing, insurance, or delivering video content to millions of users all around the world, are also using this model to deliver products, resources, or data to your end users. And you're going to need servers to power your business and your applications. You need raw compute capacity to host your applications and provide the compute power that your business needs. When you're working with AWS, those servers are virtual, and the service you use to gain access to virtual servers is called EC2. Using EC2 for compute is highly flexible, cost-effective, and quick when you compare it to running your own servers on premises in a data center that you own. The time and money it takes to get up and running with on-premises resources is fairly high. When you own your own fleet of physical servers, you first have to do a bunch of research to see what type of servers you want to buy and how many you'll need. Then, you purchase that hardware up front. You'll wait for multiple weeks or months for a vendor to deliver those servers to you. You then take them to a data center that you own or rent to install them, rack and stack them, and wire them all up. Then, you make sure that they are secure and powered up, and then they're ready to be used. Only then can you begin to host your applications on top of these servers. The worst part is, once you buy these servers, you are stuck with them, whether you use them or not. With EC2, it's much easier to get started. AWS took care of the hard part for you already. AWS already built and secured the data centers. AWS has already bought the servers, racked and stacked them, and they are already online, ready to be used. AWS is constantly operating a massive amount of compute capacity, and you can use whatever portion of that capacity when you need it. All you have to do is request the EC2 instances you want, and they will launch and boot up, ready to be used within a few minutes. Once you're done, you can easily stop or terminate the EC2 instances. You're not locked in or stuck with servers that you don't need or want. Your usage of EC2 instances can vary greatly over time, and you only pay for what you use, because with EC2, you only pay for running instances, not stopped or terminated instances. EC2 runs on top of physical host machines.
So for those who do not know, EC2 meaning, let's go back here. EC2, the meaning of EC2 is Amazon Elastic Compute Cloud. So that's what it means. Let me make a note here. Elastic Compute Cloud. Okay, that's the EC2, Amazon Elastic Compute Cloud. So basically it means a server, a virtual server. That's, they come up with a fancy name. All right, let's go.
Machines managed by AWS using virtualization technology. When you spin up an EC2 instance, you aren't necessarily taking an entire host to yourself. Instead, you are sharing the host with multiple other instances, otherwise known as virtual machines. And a hypervisor running on the host machine is responsible for sharing the underlying physical resources.
Okay, I'm gonna write down the word hypervisor. Okay, hypervisor. Correct. Okay, what's the meaning of hypervisor?
Otherwise known as virtual machines. And a hypervisor running on the host machine is responsible for sharing the underlying physical resources between the virtual machines.
Okay, so hypervisor is a distributor of resources and in the server. A distributor resources between between the servers. Hypervisor. That's an important term we can use. Okay. Hypervisor.
This idea of physical resource running on the host, otherwise known as virtual machines. And a hypervisor running on the host machine is responsible for sharing the underlying physical resources between the virtual machines. This idea of sharing underlying hardware is called multi-tenancy.
The multi-tenancy sharing underlying hardware between virtual machines. Okay. All right. So basically, multi-tenancy. Multi-tenancy. So sharing underlying hardware between virtual machines. Sure. So basically, the virtual servers share the hard drive, the hardware. So in other words, the hardware is shared by the virtual machine, meaning by the virtual machines, virtual servers. Okay, multi-tenancy. Multi-tenancy, the hardware is shared by the virtual servers. Okay, let's move on.
The hypervisor is responsible for coordinating this multi-tenancy, and it is managed by AWS. The hypervisor is responsible for isolating the virtual machines from each other as they share resources from the host. This means EC2 instances are secure, even though they may be sharing resources. One EC2 instance is not aware of any other EC2 instances also on that host. They are secure and separate from each other. Luckily, this is not something you yourself need to set up, but it's important to know the idea of multi-tenancy and have a high-level understanding of how this works. EC2 gives you a great deal of flexibility and control. Not only can you spin up new servers or take them offline at will, but you also have the flexibility and control over the configuration of those instances. When you provision an EC2 instance, you can choose the operating system based on either Windows or Linux. You can provision thousands of EC2 instances on demand, with a blend of operating systems and configurations to power your business's different applications. Beyond the OS, you also configure what software you want running on the instance, whether it's your own internal business applications, simple web apps, or complex web apps, databases, or third-party software like enterprise software packages. You have complete control over what happens on that instance. EC2 instances are also resizable. You might start with a small instance.
Hello? Yes.
Realize the application you are running is starting to max out that server, and then you can give that instance more memory and more CPU, which is what we call vertically scaling an instance. In essence, you can make instances bigger or smaller whenever you need to.
Vertical scaling. Okay. So vertical scaling. Okay, vertical scaling meaning.
In essence, you can make instances bigger or smaller whenever you need to.
Adjusting the size of the server, basically. Adjusting. Adjusting the size of the server. Vertical scaling. All right.
You also control the networking aspect of EC2. So, what type of requests make it to your server, and if they are publicly or privately accessible, is something you decide. We will touch more on this later in the course in detail. Virtual machines are not a new thing, but the ease of provisioning EC2 instances allows for programmers and businesses to innovate more quickly. AWS has just made it much, much easier and more cost-effective for you to acquire servers through this compute as a service model. There's a lot more to learn about EC2.
Service, that means CAS, compute as a service. CAS, compute as a service.
We talked about virtualization and the types of software you can run on an EC2 instance, but there is more you can configure with EC2 as well.
So do a recap. So let's go back to hypervisor, right? So hypervisor is a distributor of resources between the servers, right? Is a distributor of resources between the servers. It's called hypervisor. The next one is multi-tenancy. That means that model is the hardware is shared by the virtual service. The hardware is shared by virtual service. And we have vertical scaling. Vertical scaling meaning adjusting the size of the server, either small or big. Right? And the next one is CAS. CAAS, compute as a service. That's what it means. Compute as a service. Okay, all right, let's go to compute as a service. All right, so I wanted to really, to understand, because sometimes you don't want to just memorize it, right? You want to make sure that you understand the concept to the point where you don't need to memorize it, but you understand the process so that you don't have to, you don't forget it. When you understand the process, what it does, you'll be able to, you don't forget the concept, right? Instead of just reading it and memorizing, that's not gonna work. So you have to So hypervisor, if somebody says hypervisor, so you have to understand in the context of the multiple servers on the cloud computing, right? In the case of Amazon, AWS. So hypervisor, so you have a lot of hardware, right? You have a lot of hardware, and you also have a lot of virtual servers. And those servers, they share the hardware, okay? You know, it's not like one server one virtual server has one hard drive. That it doesn't work that way, because that's going to be a lot of servers. It's very hard to to keep up. So you have to understand from that perspective. So even though, let's say, if you have your own business, you have one server, right? So you have one server for your business. But if you take that to Amazon, you are basically sharing the resources of other companies, of other businesses. So you cannot just have your, in the case of Amazon, you cannot just have your own server for your business. No, that will be gigantic. It's not going to work. So what they do is the system is, you will be sharing the hardware, right, with other people. So basically, think of storage, right? When you go to storage, they have a lot. You have the big box. Yeah, they have compartmentalization, right? Everybody had their compartment, but everything is under the same umbrella and the same building. But everybody had their own small locker, or locker, right? This is where you'll be able to put. You're basically sharing this space. You don't just go there to the storage and say, I'm going to rent the whole thing. So that's the system that would allows the sharing of this space, right? The sharing of the hardware between the virtual servers is called hypervisor. Hypervisor. Right? So it distributes resources, hardware between the servers. Okay. And the concept itself, right? The concept of the hardware sharing is called multi-tenancy. Multi-tenancy, meaning, so you got the word multi-tenancy, right? You got a tenant, you got a multi. So you got a multiple tenants, right? So think about one building, right? So you have everybody has their own apartment. Okay, so that's the word multi coming, right? Multiple tenants, so you have multiple people renting multiple apartments, but in the same building. Okay, so think about the server is one building, right? And then you have apartments or compartments for each person. So each person has their own apartment. So that's called compartmentalization. Okay, so that's model is called multi-tenancy. It's kind of the word, the meaning is, is inside the word itself. Vertical scaling. So for the vertical scaling is basically you'll be able to adjust the size of your system, the size of the server. You can make it smaller, or you can make it bigger, depending on your need. Vertical scaling, right? This one is just a term that we need to know. Compute as a service, CaaS, compute as a service. Let's move on. What do we have? Okay, so introduction.
In this video, we are going to talk at a high level about a service called Amazon Elastic Compute Cloud, or EC2. If you remember from our coffee shop, the employees are a metaphor for the client-server model, where a client sends a request to the server does some work, and then sends a response. That example is for the coffee shop, but the same idea applies to other businesses. Your business, whether it be in healthcare, manufacturing, insurance, or delivering video content to millions of users all around the world, are also using this model to deliver products, resources, or data to your end users. And you're going to need servers to power your business and your applications. You need raw compute capacity to host your applications and provide the compute power that your business needs. When you're working with AWS, those servers are virtual, and the service you use to gain access to virtual servers is called EC2. Using EC2 for compute is highly flexible, cost-effective, and quick when you compare it to running your own servers on premises in a data center that you own. The time and money it takes to get up and running with on-premises resources is fairly high. When you own your own fleet of physical servers, you first have to do a bunch of research to see what type of servers you want to buy and how many you'll need. Then,
let's go to the next one. We covered this one already.
Now that we've learned about EC2 instances and the crucial role they play in AWS, let's talk about the different types of EC2 instances that are available. Thinking back to our coffee shop analogy, you'll remember that EC2 instances are like our employees in that they serve client requests. If we want to have a cafe that can serve a lot of customers, then we're probably going to need multiple employees, right? And they all can't just be cashiers. We also need someone to make the drinks, someone to handle the food, and maybe someone to do that cool latte art that our customers love so much. Like any business, there are a variety of tasks that need to be done, and they often require different skill sets. If we want our business to operate as efficiently as possible, it's important to make sure that an employee's skill set suits their role. In the same way that our coffee shop has different kinds of employees, AWS has different types of EC2 instances that you can spin up and deploy into your AWS environment. Each instance type is grouped under an instance family and are optimized for certain types of tasks. Instance types offer varying combinations of CPU, memory, storage, and networking capacity, and give you the flexibility to choose the appropriate mix of resources for your applications. The different instance families in EC2 are general purpose, compute optimized, memory optimized, accelerated computing, and storage optimized. General purpose instances provide a good balance of compute, memory, and networking resources, and can be used for a variety of diverse workloads like web servers or code repositories. Compute optimized instances are ideal for compute intensive tasks like gaming servers, high performance computing or HPC, and even scientific modeling. Similarly, memory optimized instances are good for memory intensive tasks. Accelerated computing are good for floating point number calculations, graphics processing, or data pattern matching, as they use hardware accelerators. And finally, storage optimized are good for, can you guess it? Workloads that require high performance for locally stored data. Now, if we map this back to our coffee shop, our cashier becomes a memory optimized EC2 instance, baristas become compute optimized instances, and our latte art employee is an accelerated computing instance type. And there you have it, EC2 instance types.
Okay, EC2 instance type, general purpose, analysis, keyboard. All right. So we're gonna take a break. This is a memory intensive work. Unintended. Okay, let's see.